Hello viewers, welcome back to another section of my tutorial. In this video we're going to solve a Bernoulli's differential equation problem. So I have a differential equation here, which is a Bernoulli differential equation, which says the y over the x plus x to the power 5y is equal to x to the power 5 multiplying y to the power 7. So we have to solve this Bernoulli differential equation. Kindly watch this video to the end and don't forget to subscribe. So you can also pause the video so that you solve it on your own, and after you test for the answer. So let's move straight solving it. Okay, so to start solving this problem, the y over the x is the same as y prime, so this problem is the same as y prime plus x to the power 5y is equal to x to the power 5 y to the power 7. Now the reason why this equation is a Bernoulli's equation is the presence of this y to the power 7, and this makes this entire equation Bernoulli differential equation. So Bernoulli differential equation is a form of first order linear differential equation where the g of x here, the function here, is being multiplied by the dependent variables to another power. So let's see, the first thing to do, or the first approach to solving Bernoulli differential equation, is by dividing through by this function we have here, and that is going to give us y to the power negative 7 y prime plus here is going to give us x to the power 5 y to the power negative 6 is equal to x to the power 5, and this is a simple linear algebra. When you divide through, you get the inverse here and y, so you get negative 6 and x to the power 5. So at this point you are going to make a substitution. So we will make, let's say, v to be equal to the y to the power negative 6 here, and after you differentiate this expression, so v prime will be equal to negative 6 y to the power negative 7 y prime. At this point we can see these terms here, y to the power negative 7 multiplying y to the power negative 4 multiplying y to the power prime, sorry, y prime, is the same as what we have here. So we make that a subject, so we get v prime over negative 6 to be equal to y to the power negative 7 y prime. Now wherever we see this, we put this one there, and wherever we see y to the power negative 6, we put v there. So making our substitution, we're going to get v prime on negative 6 plus x to the power 5 multiplying this one, multiplying v, you are making a substitution to this, multiplying v is equal to x to the power 5. Now we have got a linear differential equation, but before we can solve this, we have to make sure that the coefficient of the v prime is 1. So what are you going to do? We multiply through by negative 6, so we left with v prime minus 6 x to the power 5 v is equal to negative x to the power 5 multiplied by 6 like this. So v prime next 6 x to the power 5v is equal to negative 6 x to the power 5. So at this point I have a linear differential equation. The next thing to do is to find the integrating factor mu of t, which is given by e to the power integral p of t dt. So once I have this, p of t is the coefficient of the v here, so my mu of t becomes e to the power integral of negative 6x to the power 5 dx. So let me make it mu of x rather here. So my mu of x will further be simplified to integral, when you have this, the same as x to the power 6 on 6, and the 6 will cancel. So let's see, it's going to give us negative 6 multiplied by x to the power 6 on 6 here, and that will give us x to the power 6, that is negative of this expression, then e to the power this whole function. So our integrating factor mu of x here will be equal to e to the power negative x to the power 6. Now once we've got our integrating factor, the next thing to do is to multiply this through our differential equation here, the linear differential equation here. So we are going to have e to the power negative x to the power 6 multiplying v prime minus 6x to the power 5v e to the power negative x to the power 6, then finally is equal to e to the power negative x 6 multiplying negative 6 x to the power 5. So once we have this, we use this place, we represent it with a product rule because it satisfies a product rule here. There is a condition that whenever you multiply the integrating factor by the v, the coefficient of the v, you get an integrating factor prime. That makes this whole part turn into a product rule. So I'm going to get v multiplied by e to the power negative x to the power 6 to be equal to all prime to be equal to e to the power negative x to the power 6 multiplied by negative 6x to the power 5. Simply like this. Now my aim is to find v. So what do? I integrate both sides. So integral of v multiplying e to the power negative x to the power 6 prime, and integral of negative 6 x to the power 5 e to the power negative x to the power 6 dx. When I integrate this will cancel. The prime here will cancel the integral sign. So I'll be left with v multiplying e to the power negative x to the power 6 to be equal to. So here I'll bring the, okay, from here let's do this integration at one different side. So if you have the integral of negative 6 x to the power 5 e x to the power 6 dx, we can see that this whole term is a differential of this. Therefore, we make a u substitution which is equal to negative x to the power 6. So our du over dx is going to give us negative 6x to the power 5. Then we make the x a subject, so the x will simply be equal to 1 over negative 6x to the power 5 du. So we will put our substitution back to our integral. So we get integral of e to the power u du, which will simply give us e to the power u, and u is equal to negative x to the power 6. So we get e to the power negative x to the power 6 plus c. So once we've got that, we will continue at this side, e to the power negative x. So we are going to continue writing. So we have v multiplied by e to the power negative x to the power 6 as we had here to be equal to the answer for the integration we did, which is equal to e to the power negative x to the power 6 plus c. So at this point, what do? I have to divide through by the coefficient of v, and that is going to give me e to the power negative x to the power 6 over the same expression plus c e to the power negative x to the power 6. My v is simply 1 plus c e to the power x to the power 6. This is not the end. In the question, it was given in y. The dependent variable is y, but we made a substitution that v is equal to y to the power negative 6. So y to the power negative 6 will be equal to 1 plus c e to the power x. This is like this. So to do this, y 1 over y to the power 6 will be the same expression here. Then I'll reciprocate it. Y to the power 6 will be equal to 1 over the expression 1 plus c e to the power x to the power 6. To make y the subject, I have to take the sixth root on both sides. 1 out of 6. 1 out of 6. Therefore, I get y to be equal to the expression of 1 out of 1 plus c e to the power x 6. 1 out of 6. This is the end of the video. Thanks for watching. Kindly subscribe and don't forget to like.